For some reason, I'm really nervous. But hello, people. This is Amelia from the Doot Industries. Yes, I just called my channel Doot Industries. One day a girl can dream. This is some fun updates on Doot Eternal. And what's happening with Doot Eternal, because I haven't announced it yet. I guess this is kind of an announcement, but Doot Eternal is probably gonna make progress soon. Yes! So, I'm gonna talk with Doot Eternal. I'm gonna explain why I have a Voron Trident open here. We're gonna just talk about it. So, first of all, I'm debating just putting the Voron kit, using the part from it. This way it's more accessible, like if manufacturers want to make a Doot Eternal kit, they can just do it without a little modification. That's less of a hassle. It's cheap. We both piggyback off each other. The Voron team and I will piggyback off each other, which means cheaper and nicer parts for everyone, because if you do something very similar, the ideas are going to swing back and forth, and also the parts are going to swing back and forth. You get what I'm saying? So first of all, this is going to be different than this. I still haven't decided if I'm putting the rail on top like that, or just putting it, the parts, not the rails. The printed parts here or not. I'm gonna go over the changes the motion system is gonna have. So first of all, for now, this part's probably gonna be on the back, and that is just a cost saving measure, so you don't need high temp motors, because the Doot is also gonna be somewhat high temp compatible. I will talk about that later. The motors are gonna be in the back like this, outside the enclosure. My issue with that is that it's gonna be easier to hear the noise. However, I don't think that's gonna be too big of an issue with TMC drivers. This part's gonna kind of change entirely. This part, I'm kind of actually not a fan of this. No offense to the Warren team, it's a pretty amazing design in the printer, but I just personally don't prefer that. The belts are gonna be 9mm because I have a weird hatred for 6mm belts on 3D printers. I don't know why everybody uses 6mm belts, especially on Core XY. Like on a bed slinger for the X-axis, I'll totally go 6mm, but for the Y-axis of a 3D printer, and for especially a Core XY that has such a long belt pad, that's one of its biggest weak points, I would use 10mm belts minimum. So this is gonna change a lot. I'm not a fan of this bit. I feel like it's really easy to put a lot of leverage on this part. Again, I've never had a Voron, so I'm not sure if this is an issue. I'm gonna go over some of the design stuff. This is gonna be modified, and it's gonna be a compliant design, so the bed can expand for heat. But I also want to make sure that I can still use the tree motor design, so you can tilt the bed for some freaking, I don't know, planner experiments. Probably not gonna play off. The electronics are gonna be in the back, but that's a personal preference thing, because I'm doing that because I don't want to flip the printer every time I have to make a modification on an R&D project, for the R&D of the project. Again, I'm not sure how compatible the Voron will be yet, because the design is still very in its infancy, is that you probably lose around 100 to 80mm of Y-axis and 20mm of X-axis, because I'm going to put some sensors here for make some things automatic. I had a few designs that I scrapped off, but I'm going almost with cloning the Prusa XL. I'm not sure if that's going to be an issue with patents, but I'm still thinking of that. Because my own design uses a motor, and I kind of just stopped seeing a reason in going with a motor when you can do the Prusa XL method. There's a lot of different options, and the issue with implementing the Prusa XL is that it's designed for metal parts and things that aren't accessible to us makers. So I'm gonna try my best to do it, and I don't want to have the pins on the tool side, because that's gonna add some cost, because that's more expensive than just 2 pads. I'll see how that works out. Maybe I won't, probably won't. And it's not going to be the exact copy of it, but it's going to be very similar. And I'm also thinking of putting a force sensor, like a load cell, on the actual tool carriage, so all of the tools can be nozzle probed and save cost. I was going to put the extruder motor, like basically this, on the main carriage, and not have extruders on the actual tool heads, but my issue is that I'm going to have to use 3D printed gears for that mechanism, and I do not trust 3D prints to be good for such a delicate thing, because extruders are kind of delicate in their accuracy, because although the expansion of the plastic and all that kind of stuff is gonna make a mess anyway, I still rather not make something that's they pretty much conceal extrusion, this whole thing, the bottleneck of 3D printing. So I don't want to add more nonsense into it, so I probably want to end up doing that. Anyway, so let's talk about some of the features. There's this mechanism that I have, which is gonna be, you're gonna have a air pump here. You're gonna have 2 PTFE tubes, or I'm not sure PTFE is gonna work yet, but I'll see. 2 PTFE tubes going to the hot end, and it's like a kind of, I think it's called a burner system. somebody already did that, but mine is gonna have a mechanism that's a switch here with like a small hobby servo or something. Maybe just a DC motor, honestly. That's not important right now. What this mechanism does is that the air gets pushed to the mechanism and then it splits off into two sections. Here the switch can choose the empty path, which is gonna just blow air from the back of the printer, or it can switch off and push the air through basically a hot air resoldering rework station element, heating element. And you might think that's counterintuitive, but the idea is that you print with the colder one, and when it's done, you reheat the previous layer a little bit below its almost nearest glass transition temp, and then print the next layer. And this is not gonna probably work for PLA, but for ABS, nylon, you know, all that good stuff, there is a good chance that's gonna make it very much easier. And the issue with this printer is that once you go past 60, or I should say 80 degrees of enclosure temperature, things get expensive quick, and you have to add a lot of clever mechanisms if you don't want that. It adds a lot of parts and a lot of fuss. Especially on the tool changer, I do not want to handle that. So the idea is that these rails can handle temporary high temperatures of 100 degrees, as long as it's not for very long durations, like an hour. The idea is that, well, if you have a part heating fan, and you keep the enclosure itself at 60 degrees, and you blow 120 degrees air, say for, I don't know, I forgot what temp you to use for nylon, but for ABS, say 100 degrees, I think, or is it 80? Anyway, that's kind of up to, you know, up for testing anyways. It's gonna keep the enclosure itself at 60, which is more than enough for ABS, right? But to get extra strong parts, it's gonna blow this way, and also this way. It's gonna blow 90-degree air, and it's gonna keep the part ever so slightly warmer. And that's gonna help print higher materials or stronger materials and get more Z strength, which is one of the biggest flaws of 3D printing too, still in my mind. And with that in mind, the issue that I might face is that the part isn't going to be evenly heated, and there's a chance that the part's going to get heated, reheated, and kind of get annealed like you do. And you know what happens when you anneal parts? They a lot of times shrink. And that might just create a mess on this, but my suspicion is that since I'm only going 20 degrees extra and stuff like that, it's not going to be too big of an issue. And the thing is, I might have to develop a very complicated piece of software that handles how much each part has been cooled, each section of the bed, and actually after the layer's done, go do a reheating moves on the parts that were kind of neglected. That could work for sure, and that could solve my issues, but that's a very complicated thing to add to a slicer or a Finver. I'm probably pretty sure that would be a slicer. I think that I would not want to add that to that, but that's a whole experiment for another day. I mean, I guess for this day. So other things, compliant design for this to allow kinematic coupling for cheap. The other thing I'm going to do is to experiment with using either screws, which is kind of something I think the Voron does. I'm not sure if it's purpose or not. I'm pretty sure it's on purpose, but if you can see, you kind of add a lot of strength to your 3D printed parts by using screw, because a lot of force goes to this very rigid thing, and this is connected to the metal motor. You get what I'm saying, right? So the printer is going to, I really wanted to print this out of fancy-ish PPA CF material that has like insane, like double most filaments rigidity and flex modulus. However, as much as I would love doing that, and I can do that for free, long story, I'll get into that later maybe, but I have decided to, even though I'm going to print my own printer out of that fancy material, because why not have it for free, I'm gonna try my best. So do you see this part? Basically there's going to be dowel pin going in the middle, and that might, the good thing about 3D printers is that they need rigidity, but they don't need to be strong. You get what I'm saying? It's not like this is cutting metal, so it's not force that you're handling, it's just short bursts of a little bit of force, and for that you just want it to be rigid and not flex. You don't want it to be strong. So what I can do is to put a dowel pin or any sort of metal reinforcement or even a plate underneath, which would be very the best option, but that'll be complicated to add. Or I also might experiment with channels for carbon fiber reinforcement, like continuous, not just filament. The issue with that is that carbon fiber is a mess, and I don't want that in my lungs. But this will be 3D printed parts with a lot of metal reinforcement, which is cheap metal reinforcement. And for the plates that the Doot changer will slide on, the idea is that I will buy a brass sheet, basically a bronze, brass, whatever, steel, stainless steel might be hard sheet, and then just make a vise and make almost like, what do you call those? Not molds, forms, like, I guess. And with my clamp, I'm gonna, you know, these are not gonna be very very thick sheets, like 1mm max. I'm gonna form them into the shapes I want, like very basic shapes for the tool changer. So the last tool changer, the way it worked was that I inserted dowel pins, 2 of them, and it kind of handled the wear resist, and it worked very well. So I didn't have to. I had access to very cheap parts. The downside of that was that dowel pins have a very small contact distance, and it was hard to align them well, which wouldn't cause issues, but it was less than ideal. So basically, this is gonna have metal plates that sadly would have to be cut, which is not that hard when it's like 1mm. But hopefully the kit suppliers, oh sorry, I hope you didn't hear that. The kit suppliers would just supply the pre-cut ones, and you can just clamp it or even just be pre-deformed. And that is gonna add a lot of wear resistance to the parts that I printed without too much cost, without CNCing them. I was so tempted to CNC this bar that this goes on, this like extrusion that this mounts on, but that's just cost. And although it's like 60 bucks, I think, I just don't want to make this printer expensive, because you have to remember that you're gonna spend like $100 on just tools extra, no matter what you do, depending on how fancy of a tool you get. And that's also still an issue. Which this printer is gonna be trying really hard to be budget and gonna be around this. The budget I aimed is pretty much 1,200 to 1,500 for the entire thing, with 2 tools minimum. Because what's the point of saying the BOM for a tool changer with just 1 tool? The tools I've planned: continuous fiber tool, which is not. I have low hopes for actually making that work because it's very challenging, but I might do that if I don't get into pattern issues. If I do get into pattern issues, I'm pretty sure I can do steel wire reinforcement, because nobody has done that, and I'm pretty sure I could make it work if just really complicated. But instead of carbon fiber, just like steel bits for reinforcement. Lays down, just like carbon fiber. That's going to be complicated, but maybe it'll work. There's lots of ideas. There's going to be resin injection tools, which hopefully I have never managed to make that work back in Iran, but I had very little time. Is that I'm gonna make carbon reinforced slurry of resin. If that probably isn't gonna work, so probably just end up using resin, and that's gonna be injected into the infill in strategic ways, so you get better Z strength. That's mostly gonna be good for, certain kinds of prints. Not gonna be perfect. Yeah, and just like maybe reinforcement tools, a tool that pushes dowel pins into the print and integrates them there. There's lots of crazy ideas, and this is going to be a really cheap and nice platform for just all sorts of crazy people like me to experiment, see what they come up with, because tool changing has the potential to be so amazing, and I just want to get it into people's hands, because one person, yeah, sure, I can come up with some cool ideas, but imagine if the entire community had a tool changer that's so accessible. Can you imagine all kinds of crap they'll make? So, another exciting announcement. Please take this with a grain of salt, because I'm only just talking to them, but LDO Motors has offered to sponsor this project, which has fixed one of the hugest problems I've had, which is like stonks. Yeah, like living in my city, I've moved to Canada, it's really expensive, and it's a struggle to do a project like this, because even though this costs like, this printer that I'm showing the Voron one without my modification is going to cost like what, $1,000? I bet you that the R&D costs twice that for them, and that's going to be very hard to do. The R&D is the biggest expense, and $1,000 to me is still a lot, and I just can't afford that on my own. So I'm still talking, it's not set in stone, but the LDO did offer it. The only issue I have is that they offered to send me either a Voron 2.4 and 350 or Trident 300, because they don't make 350, Trident kits. And the issue is that this is going to end up being like 190 by 200 millimeter tool changer, which is gonna suck. But this is a nightmare for tool changers. The wiring mainly is my worry, and to be honest, it's not just the vision I have for the tool changer. All this is extra parts, all this extra fuss. I want it to be cheap as possible. Even though I would get it for free, other people wouldn't, and that's just not fair. And also the clever solution I came up with, if worst comes to worst, is that I'm gonna ask for this kit, push this down, and I have to cut the linear rails to be shorter because the Z-axis won't fit, but I'm gonna push this here, cut this, and basically put these up with a 3D printed extension, so it's like, because it's shorter. You see what I'm saying? It's not visible here, but it's way shorter. And just swap the extrusions around, and this would pretty much fit a Trident in theory, which is good. So worst comes to worst, I'll do that. hopefully that'll work because I have to also drill stuff here next to it. I guess I could ask them for the entire BOM, but that would be a huge pain for them and I don't want them to do that. Yeah, and the other issue is that I need a lot of tools. I bought myself screwdrivers. Lately I've kind of been in a huge shopping mode. I've spent way too much money. I've got myself a screwdriver, I've got myself a multimeter. I still have a lot of stuff I want to buy. There's a huge list. I kind of might need a drill. I don't have a drill, those are expensive. I need a variable bench power supply to test parts in my mechanisms, power them. That's like $60. I'm just gonna need a lot of nonsense and just like screw kits, which are like 10 bucks, 20 bucks, but they add up a lot once you buy a lot of them. And thankfully, the company I work at will give me some of the parts for my experimentation or lend me tools, which is great. But it's just not ideal. And the third issue is that I need a 3D printer to print the parts. And although my work is generally generous to offer me their fancy industrial printers, I'm not gonna mention where I work because that just feels kind of uncomfortable. But they have offered me their fancy, amazing printers for printing like freaking CF nylon, not just your average CF nylon, like PPA, high temperature nylon, with like rigidity that's just insane. Like those things can replace metal in some applications. I mean, obviously not all, but they can almost replace metal. So that's good, but the issue with that is that I go to work once a week and it's an hour transit, which is not, it's kind of short, right? But I have some physical health issues that makes it harder for me to do that. It's really draining for me. And the other issue is that it's at work, so when I go to work, I'm working, right? And I don't want to just spend most of my time that they're paying me salary to work on a hobby project. And I mostly work Sundays and Saturdays on these sort of projects, and I can't go to work. I mean, technically probably could, but it's just a pain to go to work on Saturday and Sunday. So there is obviously a solution here, which is ask another company to sponsor the printer I'll use to print this printer. But that just feels wrong ethically. I'm not sure. Am I being crazy, or is that okay to do? Like, I feel wrong asking for two printers. Like, I would obviously go to maybe another manufacturer because, you know, two printers from one manufacturer kind of seems weird. But yeah, it would be amazing. I could ask LDO for the printer, like just the plain Trident that I will use for the project, or the 2.4. I like the Trident a lot more, if I'm being honest with you. I just don't get the point of doing all this. Like, so much extra complication, extra parts for practically, in my opinion, no real gain. Sorry if that's throwing shade. I mean, it's just personal preference, right? I just prefer the good old simple design. Like, it works so well, right? Why change it? So yeah, what do you actually think? Is that gonna be an issue in your opinion? Is that ethical? I have no clue. And if you know any good companies that might sponsor the electronic side of things, let me know, like the power supply, all that. Yeah, and that's the state the Doot changers now. And I have a lot of cool ideas. The budget's like 1,200 to 1,500. If you have any requests or ideas, this is pretty much for me, for the community, because with the access to my company's tools, I can make myself something really fancy. But the issue is that other people can't make it, then what's the point, right? I want all my hard work to be something that other people could benefit from, right? And probably for free. I mean, not probably, definitely for free. Especially since I'm getting sponsored, I don't need to worry about making the money back that much. So this is pretty much for you. So I'm asking you, do you have any cool ideas? Do you want to offer your help? I'm not talking about anything like even, I'm talking about even stuff like writing documentation for other people, or just giving your advice to me. If you're an engineer with a degree, because I'm a hobbyist, I'm actually a software engineer, so I'm not a mechanical engineer. So if you have cool ideas or advice to me that you could lend, please let me know. I would love that. If I want to join kind of the project, I probably could handle that, making a Discord server for it. I might do that. Yeah, just one requirement for this project is that if you're gonna tell me my ideas aren't gonna work and try to depress me out of it, I'll freaking throw you in the pit of fire, because everybody just wants to tell me that it won't work. I don't get why. Like the Doot changer, they told me I could never do it, but I did, and it worked fantastic, and I loved that printer, and honestly worked way better than the Prusa XL. Sorry, no offense, but that printer kind of is disappointing as hell. It worked way better than the Prusa XL, and it cost like $650 US back there. Like, people told me I could never do it, but I did, so I'm not gonna listen to anyone telling me my ideas are crazy or silly. God, this video is so long. Anyway, TLDR, Doot Eternal is now being made. LDO offered to sponsor this project, which is really amazing news for me, even though I might actually not work out because of the issues with the kits. They make different kits than what I need, but they will for sure sponsor some of the parts. Even if that doesn't work, and I'm sure they can send me the rails at least, because they did offer me a lot of nice things. And yeah, that's it. You have any cool ideas or any requests, honestly, even, because I'm doing this kind of like for the people, you know what I'm saying. Just let me know what you would like to see in a tool changing printer. Tell me what you don't like about the printers. And yeah, and it's gonna have automatic calibration, by the way. There's two mechanisms. One is a simple switch, like the projectile, and you might use the force sensor inside. The other one is a laser, which is faster. Just sweep, and just pretty much get the middle, and that's gonna be nice. But I'm worried about filament deposits on the printer messing with the sensor, so that's why I might not do that. But yeah, this is it. I have actually some notes here that I want to open because it's my personal notes, but yeah, that's all my ideas. Yeah, it was just a silly update. I hope you enjoyed it. I guess there's not so much to enjoy. And yeah, that's it. Bye. Sorry for the long video. It's gonna be so fun. We're gonna do so many fun things. And I just realized that this Fusion 360 runs like crap on a Mac, which I hate because I love my Mac. It's my company laptop, but they let me do personal projects on it and stuff, so I don't have any other computers. And I don't want to spend like $1,500 on a computer, Canadian, you know. Oh wait, sorry, I should mention I'm talking about Canadian dollars here. $1,500 Canadian, okay? Not US dollars. But anyway, I don't want to spend that much money on a computer, so I'm probably just gonna deal with this. It's really slow sometimes, but it's a fast laptop. You just don't see the used CPU being used. Just Fusion. It's just the way Fusion is. I could get a SolidWorks license. Oh wait, it doesn't run on Mac. God damn it. Anyway, bye and have fun.